Hello, everybody. Today we're going to continue on with section 6.1, exponential growth and decay. These are day 2 notes. So you could have already have gone through the review up here, but to quickly go through that, for A, if you look at that, hopefully to determine if it's growth or decay, you are looking at the base. Here is the base, here is the base. Okay, remember that for growth, the base will be bigger than 1, and for decay, the base will be between 0 and 1. So very quickly, looking at this, you can see that for number 1, the base is definitely bigger than 1, so this would be a growth function. For B, what do you think that would be? That would be decay. And looking at C, our base is 1.08. That is slightly bigger than 1. So that is definitely still going to be a growth function. Yesterday, we also talked about exponential growth formulas or models and exponential decay as well. So as a reminder of what we talked about yesterday, let's write those formulas down because we will be needing them today. The exponential growth formula is y equals a times the quantity 1 plus r raised to the power of t. Remember, t is the time. And decay, y equals a, except in the parenthesis, we have 1 minus r to the power of t. Now, if you're wondering what the different variables and different parts of each of these models represent, then take out your notes from yesterday. We wrote that down in our notes yesterday. Okay. So go ahead, pause this video. I want you to take a moment and go through the investigation, writing down what you think the answers are to each one of these with the help of your notes from yesterday. Okay. So after you have paused the video and tried these problems, let's go ahead and write down our answers and check them with mine. So for the first of all, we're using this model here. The model is our formula for the exponential function. So because of our base being between 0 and 1, right, we can say that this is definitely going to be a decay model. That 0.63 is what's telling us that. It says then, what is the percent of increase or decrease? Well, ours is decay, so it's not going to be an increase, it's going to be a decrease. When they're asking you for the percent of increase or decrease, they're asking you for the value of r. And remember, r is part of the parenthesis. So basically what you have here is 1 minus r, right? So I'll do this work over here. 1 minus r is 0.63, right? So you could solve that for r. The other option here is that you could just take the difference between 1 and 0.63 on your calculator. If you wanted to solve this, you would subtract the 1 on both sides, so that'd be 0.63 minus 1, giving you negative 0.37. Divide both sides by negative 1, you get r equals 0.37. The other thing that you could do for this problem is you could just do 1 minus 0.63, and that will give you the same value. Now remember, that's not a percent. To make it a percent, we must times it by 100, which moves the decimal place 2 places to the right. So I get 37%. So there we go. All right. The initial amount here is always represented by the variable a. And in our case, a equals 20. So the initial amount is 20. And then for D, it says, what is the value of the model when t equals 3? Round to the nearest tenth. So all you have to do is take your problem and plug that in, that value of 3 in for t. So on your calculator, you should always do the 0.63, the base, to the power, and then times that to the initial amount in front. So I got 5.0, and that would be, I guess, rounded to the nearest tenth. And this would be your answer. All right, moving on, let's look at some other examples here. It's just a little bit more practice. So the value of a car, Y, in thousands of dollars. And so what that means is that this number in front, this initial amount, 18, actually means 18,000. That's what that means. So if you wanted to rewrite it as 18,000, you could, but I think it's just so that we don't have so many zeros all over the place. So that's basically what they're talking about. So here we have our model, y equals 18 times 0.82 to the power of t. T, again, is the number of years since the car was new. So it says, tell whether the model represents exponential growth or decay. Well, it's definitely a base that's smaller than 1, so that is decay. And then it says identify the annual percent increase or decrease. So here's where you're going to find it's not going to be increase, it's going to be decrease. The reason why it says percent increase or decrease is because they don't want to give away the answer to part A. And most of the time, a car value does go down. They often will use the word depreciates. So that's another word for decrease if you didn't know that. So again, you could set it up like this one up here and create an equation, but realizing what's happening there is you're just doing 1 minus 0.82, and you can go ahead and do that on your calculator. 0.82, you get 0.81. And again, they're asking for a percent here. So you're going to have to times that by 100 to get your answer. So that's going to equal 18%. So let's find the value of the car after 5 years. So if T represents number of years, that means 5 is going to be your T. So let's go ahead and plug this in. Go ahead, pause the video or take a quick moment and go ahead and plug that into your calculator. You really need to make sure that you are understanding how to calculate this correctly without someone's help. And I got, it doesn't say what to round it to. So let's just do we'll just do the tenths. So that's going to be 6.7. So remember, that's 6.7 thousand. So 66,700. So 6.7 thousand, if you want to give it a title. Or if you want to write it out like if you want to put this 18 as 18,000, you can go ahead and do that. And if you did that, you would get like 6,700. So that would be $6,700, right? Another way to think about it. Let's look at part D. And in part D, it says estimate when the value of the car will be $9,600. Now, here's the thing. First of all, we know that in 5 years, it's going to be 6.7 thousand or 6,700. So we know it has to be less than 5 years, right? So it's going to be 1, 2, 3, 4, or 5. So not 5, but 1, 2, 3, or 4, somewhere in there, right? So what we're going to do is we're going to take our model, y equals 18 times 0.82 to the power of t. And remember that this is the ending value. So what you're going to do is you're going to plug that value in for y. Now, I'm going to go ahead and keep it written as like 18,000, 6.7 thousand. I'm going to write this as 9.6 thousand. So when I plug it in for y, I'm going to have 9.6 equals 18 times 0.82 to the power of t. So basically what we're looking for here Remember, t is kind of like your x value. We're looking for what is the x value when y is 9.6. Honestly, I don't know what it is. So what you could do is you could start plugging in, what do you get when t is 1, t is 2, t is 3, right? And we could keep going with that. That could take some time. So what we can do is we can use our graph because we have not yet learned how to solve something like this. So what I'm going to do is I'm going to go to Desmos. You can see here I've already typed into the equation. So it's y equals 18 times 0.82 to the power of t. So what I'm looking for is when this value of y is 9.6. So if you go on a Desmos graph and you drag, you can not drag, but you can click points, and wherever you click, it'll give you the point, right? So I'm just gonna sort of drag this along until my y value is as close to 9.6 as I can get. That's 9.2, 9.4. I think that's about as close as I'm going to get, and to me, that's close enough. You can see that it's going to be somewhere around 3. So 3.17, I know that that's not exactly 9.6. So if you just wanted to say 3.1, I think that would be fine. 3.2, if you round it up to 3, that's totally fine because we are talking about number of years. So maybe you just say a little over 3 years, right? So I can go here to this, and I'm going to say that about 3 years. And I'd be okay with that answer. If you want to say a little more than 3 years to be a little bit more exact, that's fine too. So if you get something like this where they give you the y value and they want you to find t, or in our case, that's the same as thinking x, go ahead and use Desmos to help you find that answer. Okay, so here is a you try. So I want you to go ahead and give this one a try on your own. So you're going to need to pause that video. And when you unpause it, you'll get to see all your answers to check to see if you're doing it correctly. So hopefully you had a chance to try each one of those, and you can check your answers. I have them all circled and boxed. I even put all the work there. So if you needed to pause the video to look at my work to see what I did to get to the answers, you can go ahead and do that. I did want to specifically look at D because with D, they ask you to estimate what year the population will be 92,000. So if you just said 3 years, what you were looking at on your graph is you were looking at when the population when the y value hit 92 on the graph. So if you go to Desmos and you look where that y value is 92, that's over here somewhere, you'll see it's about 3 years. So the answer isn't 3 years. The answer is 3 years after 2019. So that would be the year of 2022. Okay. So a few things to look at there. The other thing I wanted to point out here is that this was growth. So to get your annual percent, this was a decrease. An increase, not a decrease. Okay. So it's just a difference of 1.02 and 1. So again, you can take that 1 plus r formula, set it equal to your base, and you can solve it to get your percent. Make sure if you only had 0.02 as your answer that you times that value by 100. And the reason I used 5 for my value of t here on C was because the difference between 2024 and 2019 is 5 years. Okay, so the next thing that we need to talk about is compound interest. Compound interest is actually something that's used a lot in accounting with any loans or credit card balances. Compound interest is something that is used. So it is definitely something that can be related to real life, and people who are in finance often use this formula every single day. Okay, so let's talk about what all of the parts of the formula mean after I write it down for you. So the formula here is capital A equals capital P times the parenthesis 1 plus R over N to the power of N times T. So N times T is all in the power together. Okay. In this little paragraph up here, it talks about what all of the different parts mean. So I don't necessarily need to write that down again because it's all up here in that paragraph. Okay. So it says the initial amount, which is P, right? That's the same place as the initial amount before. This is still your initial amount, right? The amount A, this capital A, that's the how much you have, like the ending balance, I guess you could call that. Another word for that, I guess, would be ending balance. Final amount, you can say that. T still stands for years. R still stands for your rate. Make sure, again, your R is expressed as a decimal. And then this N is new. How many times is it compounded per year? So how many times is the this interest calculated and added to your initial balance, the balance that you started with, right? So there's different ways that things can be compounded. If you look down here below, it says compounded quarterly. Here it says compounded monthly. Here it says compounded daily. These aren't all of them, but it's just some examples. So for example, compounded quarterly would be 4 times in a year, right? So there's 4 quarters in a year. So every 3 months is considered to be a quarter. So you're breaking the year up into 4 parts, right? So that means for this one that the N value would be 4. Okay. Moving on to monthly, compounded monthly. In a year, there's 12 months, so N would be 12. Compounded daily, let's just assume it's not a leap year, so we'll say that the N value is 365, right? And I'm not going to do all of these. I'm going to go through the first one with you, and then I'll put the answers for the other two if you want to try them on your own. So let's go ahead and do example 3 together. So we're going to go ahead with the formula. It says find the balance after 3 years. So we don't know A, so A will stay as A. There's not much work to show for these problems. It's basically showing me what you put into the formula, which is what you're putting into your calculator. So you do need to show this part. So A equals, I don't know the ending balance. The principal amount is your initial amount. So what did we start with? Well, when we deposit something into an account, that's what we start with. So I'm going to start with 9,000. And then we have in a parenthesis, 1 plus, that's just part of the formula. And because it says the word compounded, if you see the word compounded in the problem, that means you need to use the compound interest formula, which means this next part's going to look a little different than the ones that we did in the previous notes. So you're going to go with your rate. Our rate here that they gave us is 1.46, right? But we need to write that as a decimal. So to get that value, you can divide it by 100, or you can just move the decimal 2 places to the left. So your R is going to be 1.46 divided by 100, which is 0.0146. I'm just going to plug that in over here. That's 4 divided by N. Now, since it's compounded quarterly, my N is 4. Close the parenthesis. In the formula, it's N times T. Well, my N times T is going to be 4 times the number of years they gave us, which is 3. So that would be 12. And you can go directly to writing the 12. So doing this in the calculator, get your calculator ready because I'm going to tell you the order that you should do this in. And what you want to do is you want to do the whole thing in your calculator and you do not clear it out. So you don't put this in and then clear it and then do the next calculation. Just keep the number in there and keep doing more calculations on top of the next one. So for this problem here, you're going to do 0.0146 divided by 4 first. So do that first. Okay. Take that number. Don't clear out your calculator. Take that number and add 1 to it. Okay. Now you're going to take that number. Again, don't clear out your calculator. Take that number, you already have it in there, and then you're going to raise it to the power of 12. Okay? So then now you have another number. You're going to take that number and times it to the number in front. And if you do it correctly, you should get somewhere around 9,402. That is your ending balance. Okay? That means that at this annual interest rate over a year, you gain 1.46 compounded quarterly, right? You're going to end the year with $9,402. So basically, your account has gained $402. If you did not get that in the calculator, you're going to need to try that again. Rewind this video, listen to me go through it again. And if you're still having trouble with it, you can ask for help in class. So now you can take the time to do the other two problems. I will put the answers here so that you can check that you are doing it correctly. So if you try number 4, you should get A equals 9,066. And if you try number 5, you should get 7,466 again. So, and for all of these, I'm rounding it to the ones place. So these, you don't have to do 4 and 5, but I would highly recommend trying at least one of them so that you can see if you can plug everything in correctly on your own, and also the calculator work, which tends to be the most challenging part of these problems. Okay, so you will get more practice with this. So if you need to go back to any parts of this video, you can. But best of luck with your practice.